Yes, welcome to the online chemistry classes, my dears. So today, actually, previous classes I have explained about the physical properties of ammonia for ICSE 10th standard students, and few chemical properties of ammonia we have learnt. Then have explained what is that means catalytical oxidation of ammonia as well as uh, combustion of ammonia. So today we are going to learn about few more chemical properties of ammonia. That is very importantly. So basically, first point you have to remember the properties of ammonia. Properties of ammonia NH3. Chemical properties of ammonia NH3. Here you're supposed to remember few points here. Ammonia behaves as a alkali. Why it behaves as an alkali? Ammonia gas basic in nature. How ammonia gas is basic in nature? And we know that ammonia basically made up of two nonmetals. This ammonia gas basically made up of two nonmetals. Almost covalent compounds exist when the covalent gases like sulfur dioxide or carbon dioxide, when they dissolve in your water, basically they produces a acidic acids like sulfur dioxide. Suppose if you take sulfur dioxide in water, so that produces sulfurous acid H2SO4 sulfuric acid. But how that ammonia is made up of, basically that is a nanometals, and how it acts as a basic, that is the point. So why it acts as a basic means, so ammonia made up of one atom of nitrogen and three atom of hydrogens, and the nitrogen atom having valence electrons of 5, out of 5 3 will be the valence electrons. These three valence electrons shared with three different hydrogens to form ammonia gas. Whereas here one lone pair electron present in the nitrogen of ammonia, that is lone pair electron. What do you mean by lone pair? Lone pairs are nothing but a pair of electrons which are not contributed in a chemical bonding, which are not takes part in a chemical bonding. So that lone pair electrons, due to the presence of lone pair electrons, this ammonia behaves as a alkaline. How? So how it behaves as an alkaline means, ammonia gas when it dissolved in your water, H2O that produces NH4OH as a base, that produces a hydroxyl group. So whatever the substances, when they dissolved in your water, if we'll get a hydroxyl ion means, then that substances we can call them as a basis. So this is the substance. Ammonia is a substance, a gaseous substance. When it dissolved in your water, it producing a hydroxyl. When it dissolves in your water, it producing a hydroxide. That is means ammonium hydroxide. Ammonium hydroxide contains a hydroxide ion. So basically, generally, just remember, basic compounds only produces a hydroxide. So on this basis, we can consider the ammonia is a basic solution. Ammonia is a basic solution. And later on, so liquor ammonia, this is liquor ammonia is nothing but ammonium hydroxide. Ammonium hydroxide itself is a liquor ammonia. Ammonium hydroxide is itself is a liquor ammonia. Okay, now basic nature of ammonia, this is the basic nature of ammonia. Ammonia, when it dissolves in water, it produces a hydronium ion. That hydronium ion carry over the basic property in the aqueous solution of ammonium hydroxide. That's all. Now next property, what is that next property? This ammonium salts, you should remember, this ammonia basically reacts with a few acids. Reaction of ammonia to produce a ammonical salts. Reaction of ammonia NH3 with some acids, okay, acidic solutions with acids to produce ammonical salt. Ammonium salts. So what are the salts produced? What salts will get when ammonia is reacted with the acids? Very simple. Just remember, ammonia, a pungent odorless gas, when it reacts with the HCl acid, hydrogen chloride or hydrochloric acid, dilute hydrochloric acid, basically we'll treat here with the dilute hydrochloric acids. So this hydrochloric acid with ammonia, it produces ammonium chloride, NH4Cl. This is what a ammonium chloride salt. Ammonium chloride salt. You can observe that Yes, we can observe there a dense white fumes formation. That is what ammonium chloride. So NH3 when it reacts with HCl, it forms a dense white fumes. Dense white fumes. This is what your observations. So they may ask you in board examinations. So observe what write your observations when ammonia reacts with the HCl. When ammonia reacts with the HCl, it forms a dense white fumes of ammonium chloride. And the next reaction, what happens to the ammonia gas when it reacts with the H2 or NH4, I mean H2SO3 or HNO3, any one acid you can take. What happens to the here? So nitrogen displaces hydrogen. Basically, nitrogen is highly electronegative, displaces less electronegative element from the compound. Very simple. Okay, ammonia reacts with the, it's not displaces basically. Here, ammonia contains a lone pair electron. That lone pair electron contributed to the hydrogen and merged to form a NH4 plus ion, and nitrate is NO3 minus ion. So together we'll get a ammonium nitrate compounds will get. The same way, NH3 when it reacts with the H2SO4 sulfuric acid, then here we'll get ammonium sulfate NH4 twice SO4. These are the products what you will get. So this is what how the ammonia reacts with the other acids. Now let us go to the next point. How liquid ammonia reacts with the acids. Liquid ammonia is nothing but ammonium hydroxide. Very simple. So liquid ammonia with dilute acids. Now let us go here. Liquid ammonia. What is a liquid ammonia? Ammonium hydroxide itself is called as a liquid ammonia. Treated with the acids, dilute acids, definitely will get the salts like NH4Cl along with the water. So this is also we can call neutralization reaction. Weak acid with strong, weak base with strong acid. Here definitely will get a strong, weak base with strong acid. We definitely here will get a solution, acidic solution. Let's see, you should remember. Okay. Now next, ammonium hydroxide again reacts with the H2SO4. What you will get? Definitely you can try to write the products NH4OH plus HNO3. What type of product you will get? So you try to write it. So not, I will not give. Okay, next let us go to the, this kind of reactions are also called as neutralization reaction. In this time, in this particular duration, you have to recall the definition for the neutralization reaction. Neutralization reaction is nothing but a reaction between acid and base to produce salt and water. That is what we call as a neutralization reaction. Neutralization reactions are resulting in the formation of ammonical salts and water when ammonium hydroxide reacts with the dilute acids. So this is what. Next point is ammonical salts like ammonium chloride. There is a note point you have to remember. This ammonium chloride, whatever there is there, that ammonium chloride is a sublimable compound. That means this is actually solid. The solid can directly convert it into a gases like ammonia and HCl, hydrogen chloride gas, on heating. And again, after cooling that HCl and ammonia gas on cooling, again the HCl, that means a gas of hydrogen chloride and ammonia chloride, on cooling it gets converted into again dense white fumes. This is the point. Next, the property of ammonia is the chemical property of ammonia. That is, ammonia gas is a basic in nature. Already we had a discussion, because of that produces a hydroxide ion. How this ammonium hydroxide, how the liquid ammonia or ammonium hydroxide reacts with the ammonium hydroxides with different salt solutions. Some salt solutions, that is what we call as precipitation reactions. So what is the role of ammonium hydroxides in precipitation reactions? With some salt solutions. So this is basically ammonium hydroxide is used to identify the ions present in a given salts, unknown salts. There we will use this ammonium hydroxide as a reagent, NaOH, sodium hydroxide and ammonium hydroxide. How means this ammonium hydroxide dissociates in the solutions of salts and forms a characterized color. There will be a change in color of the product. So with the help of the change in color of the product and solubility of the salt, we can easily recognize the type of cations present in a unknown salts. So there we'll use this ammonium hydroxides to ammonium hydroxide in a analytical chemistry to analyze the kind of ion cations present in a salt solution. Let us go with now. So metallic salts, for example, any metallic salts, for example, when we treat a ammonium hydroxides with iron sulfate, FeSO4. Basically, you should remember iron sulfate color is green in color, light green in color. When we treat ammonium hydroxide, iron sulfate produces, this is also aqueous in state, this is also aqueous in state. Both the aqueous state solutions, when they mix with each other, it gives a product with the color of dirty green. Then among those two products, one product should be insoluble. That is what we call it as precipitate. It produces FeOH twice. It is insoluble along with the NH4 twice SO4. This is actually solution. Okay, so balancing equation here. So initially the color was green in color, whereas after making reaction, that forms a reddish brown precipitate. Sorry, after it forms a dirty green precipitate. Dirty green precipitate. Okay, after it forms dirty green precipitate. What is the reason for the dirty green precipitate formation? Green precipitate. Here, precipitate is nothing but insoluble salt. Insoluble. So here, iron sulfate reacts with ammonium hydroxide, forms iron hydroxide with ammonium sulfate. Here, iron hydroxide, iron 2 hydroxide, or ferrous hydroxide. It gives a characterized color, that is what dirty green precipitate, which is insoluble. Next reaction, what happens to the ammonium hydroxide when we treat with the FeCl3, iron 3 chloride, that means ferric chloride. So basically the initial color of ferric chloride is yellowish color. Okay, initial powder, this is actually yellow powder. And the one more property of ferric chloride is this is deliquescent substance. Deliquescent substance. What do you mean by deliquescent substance? Deliquescent substances are nothing but the substances, when they expose us to the atmospheric air, those substances absorb moisture from the atmosphere and gets dissolved in that moisture and becomes a solution, and it turns into a solution. That kind of compound, this is FeCl3. This is yellow in color, yellow powder. So when we exposes this yellow powder to the atmospheric air, that absorbs moisture and gets dissolves in it, and it gets converted into a solution. That is the reason. So such kind of compounds we call it as deliquescent substances. Now what you will observe here, what is your observation during this reaction? They may ask you for 1 mark or 2 marks in your board examination. Definitely they will ask you. Ammonium hydroxide treated with the FeCl3, it produces FeOH thrice iron 3 hydroxide or ferric hydroxide, but this is also a colorless. This is also insoluble along with the here NH4. Here what type of product you will get means NH4Cl. Okay, NH4Cl will get here 3. I would like to write here also 3. Okay, what is the observation? What's your observation during this reaction? Very simple observation. Fe3 plus Fe2 plus ions forms green color, whereas Fe3 plus ions form dirty, a reddish brown color, not dirty actually, reddish brown. So here we will get a reddish brown PPT. That means precipitate of FeOH thrice we get. So this is the point. Okay. Next point, next thing is, let us go to the, and on excess of ammonium hydroxide with these precipitate which are insoluble only, it remains their state as insoluble. Okay, next, third one, ammonium hydroxide treated with ammonium hydroxide treated with some other salts like copper sulfate. The copper sulfate salt color is CuSO4. Copper sulfate color is blue color. So let us treat with the aqueous solution of ammonium hydroxide with the aqueous solution of copper sulfate solution. When we treat, the interchanging of or exchanging of ions takes place. Here we'll get a pale blue color of copper hydroxide along with the ammonium sulfate solution. Ammonium sulfate solution. This is actually a pale blue color, pale blue precipitate. This is also a precipitate, so which is also insoluble in water, which is also insoluble in the solution, But when we treat an excess of ammonium hydroxide to this particular mixture, what is that mixture? Resultant mixture, CuOH twice plus NH4 twice SO4 plus now I am treating excess of NH4OH. Okay, this is excess of NH4OH. Definitely here we'll get a soluble salt of soluble salts or salt of tetramino copper sulfate. Tetramino copper sulfate. So I can write like the formula, that is CuNH3. Tetra means 4, SO4. Tetramino copper sulfate will get along with the water, but the tetramino copper sulfate is inky blue in color. Inky or deep blue in color. Deep blue in color. Blue solution. Inky or deep blue solution. Soluble solution. Soluble solution, inky or deep blue soluble solution. Okay, so this is the point. So on excess of ammonium hydroxide to the resultant mixture, that produces deep blue or inky blue soluble solution. So this is what about the observations as well as chemical behavior of ammonium solution with different kinds of salts and ammonium solution with acids, and how ammonia behaves as a basic compound. In next class, we'll learn about the chemical properties of ammonia as a reducing agent. Thank you for watching, and if you like my video, you can share and like and subscribe my channel. Thank you.